Before going to that edge case, I will just explain once again how we are finding this length so that we are going to check if it is the maximum length or not. We are going to find the length. So how is this done is here we are find let's in this case we have the total sum as 9. We need the sum of the we first assume that there is some 3 and then we are finding the remainder 6, right? And we are going to check if this 6 exists in the hash map. Yeah, in this case it exists in the hash map. So to find the length of the subarray whose sum is equal to 3, what we are going to do is, we know if 6 is in the hash map, then there will be an index associated with that 6 as well, right? It is 2 here. So this 2 means that the index 2 represents that from index 0 to 2, this sum is 6, right? From index 0 to 2, including 2, the sum is 6. So this subarray is indexed from 0 to 5, right? Using this index you can say this till this the index is 0 to 5. From 0 to 2 it is 6, and 0 to 5 it is 9, and we need the sum of 3. So the rest index, that is from 3 to 5, will be the uh, in will have the sum of some 3, right? So using this only we are finding that okay, this is the length will be found in this way, and we are going to check if this is greater than the maximum length which we have found. If it is so, then we are going to increment the length and we are going to find the maximum length, right? So there is one edge case here. This will work, but for not all the cases. I'll say why. So let's take an example. Okay, let's take an example here equals to 2 0 0 3, and then k equals to 3 again, right? So the same way we will take pre-sum equals to 0 first for now, and then len equal to 0 for now, okay? And then same case steps we will do for this one here. So we will take a hash map, and then we will have a pointer first, and for this one we will increment the pre-sum as 2, and it is not equal to 3, so we are going to increment, and before that we are going to add it here, right? 2 comma 0. So when we are adding it, we are incrementing the pointer here. It goes to 0, and now the pre-sum remains 2 as such, right? If pre-sum remains 2, we are in a going to add this into the hash map. We have 2 already in the hash map, so we are going to change the index, right? 2 comma 1, and we are going to go to next point, right? Here in the next pointer it's going to be 2 comma 0 comma 0. Again the pre-sum is 2. uh, it 2 is already in the array. We are going to increment this to 2 comma 2, right? And then again we are going to increment the pointer. It's going to be 3. Now the sum is going to be 5, right? And we are going to check again 1 2 3 4. If the sum is 5, total sum is 5, the required sum is 3, the remaining sum is going to be 2. If the remaining sum is 2, we are checking this if this exists in the hash map. Yes, it exists, and the associated index value is 2 now, right? If the associated index value is 2, so the length of the subarray which has 3 is going to be 4 minus 2 minus 1, right? So it will be, sorry, 3 minus 2, it is going to be 1. So this will be the length of that one, so maximum length will be 1. So the required answer will be 1 here, but that is not the case. If you see this array, the maximum subarray sum can be 0 0 3, that is length will be 3. So in this case the our algorithm is not working. So what wrong mistake we are doing? So here we are incrementing the, that means we are modifying the hash map whenever the sum is the same, right? So if we avoid this, that means we should not change this index in the hash map if it is already present in there. Okay, and if the prefix sum is not changing. So if we include this condition here, our code will work fine, right? So it will be something like, if pre-sum map dot find sum, if this sum does not exist, that means if at all it does not exist in the map, only then we are going to add it in the hash map. Otherwise we are not going to add it. So now this is the final code, and this will work for all the test cases, and this will work even if the array has negatives elements inside it. Even if there exists some negative elements, this will work fine. And if the question is asked like the array contains only positive numbers or positive numbers along with zeros, there exists another optimal approach. That approach will not be working for negative numbers, and that approach is just like having a two pointer approach. Yeah, I will explain that approach right now. It's just a sliding window, you can say, or two pointers, whatever it is, one, two, three, one, one, three, three. So let's say this is the array. Okay. So in this method, what we are going to do is, okay, let's say k is equal to 6 is the thing we need to find. So first thing is we are going to check the sum the same way. Okay. So let's take sum equals to 0 initially, okay, and then same way length equals to 0 for now. So if sum is 0, we're going for first element. Sum will be 1 and it is not equal to 6. So move on to next element 2. Sum will be 3 now. Again it's not equal to 6. So the next element will be 6 and it's now equal to 6, right? And at this point we're going to check the length of this subarray. Length of this subarray is 3, so we are incrementing the length 3, and then again we are going to next subarray, next element, and now the sum is going to be 7, and here is where our method starts. Since this sum is greater than the required sum, what we are going to do is we are going to increment the starting pointer, right? Whenever the sum is getting larger than the required, we are going to push the required subarray one step further, one step further. So when we are pushing, so now if we increment this starting pointer, so this element will be cut off, so it will be starting from 2, right? So now if we see 2 plus 3 plus 1, it will be 6, so the sum is going to be 6 now. And then again we are going to increment the next pointer, it will be 7 right now, and 7 is again is greater than 6. Okay, now here we got 6. What is the maximum sum right now? So it will maximum length 1 2 3, it's again 3, so we are just going to leave it as such. Whenever we are getting 6, we are going to check the length. If it is greater, we are going to increment the length. If it is lesser, we are just going to leave it as such. Okay, so now it's again 7, so again we are going to increment the starting pointer, it will be starting from here right now, so we are going to subtract the element from the sum. Now it's going to be 5, right? Now 5 is less than 6, so we are going to increment the ending pointer and check. Now the sum is going to be 6 again. Okay, so now it's equal to 6, we are going to check the you know the length of the subarray. Now it's going to be 1, 2, 3, 4. It is greater than the maximum one, so it's going to be 4 here, right? We are going to change the element 4, and then the next we are going to move the pointer again and add this into the sum. It's going to be 6 plus 1 7. Again, 7 is greater than 6, so we are going to increment our first pointer. Now it's going to be from this point. So we are going to subtract this element from the sum because the subarray is going to start from here right now. So decrementing that, 7 minus 3, it's going to be 4, right? Now 4 is less than 6, so we can just move on to next pointer. So it will be 3, adding this into the sum. It will be 7 again. 7 is again greater than 6. So we are going to increment the pointer, right? So increment the starting pointer and then subtracting this point, it's going to be 6 again. Now 6 is equal to the required sum. So we are going to check the maximum sum, maximum length of this subarray. 1 plus 1, 2, 3, 4. It's equal to 4. So it will be just as it is. Again, we are going to add the last element now. It's going to be 6 plus 3, 9, right? Since 9 is greater than 6, we are going to increment the starting pointer. It's going to be 8. As in even 8 is greater than 6, so again we are going to increment the starting pointer. So subtracting that, you will get 7. Again it's greater than 7, so again we are going to increment it. So it's going to be 7 minus 1, 6. Subtracting these elements one by one, so now we got 6. So since 6 is equal to the required target, we are going to check the length. The length is going to be 2, which is less than 4, so we are just not going to consider that. So finally, whatever the element we are present in the length is going to be the maximum length. So I hope you get it. It's just having a one loop, and where we are going to check the sum one by one. Whenever the sum is equal to the target, we are going to check the length, and then whenever the sum is getting greater than 6, we are just going to push this subarray, the starting index. So whenever it's greater, we are going to push one side. So fine, ultimately we are going to find the we'll get that final length, maximum length, right? So I will just give a code for this one. It's just simple one. So I say int long longest sub array, int here are comma int. Okay. So it will be, first we will initialize the pointers int left is equal to 0, right is equal to 0, and then the sum be let's take the sum be the first element at first. Okay, anyhow we can just have it 0 and then add it whenever necessary, but we will use while loop here. I will say why. So we need to have an sum at first. Anyway, the first element will be the sum at first step, right? So we will have that in this sum, and then we will have max len equal to 0, initialize that as well. So while right is less than n, we are going to have this loop whenever the last index, right is the last index here, whenever the last index reaches the last element, we're going to stop it, right? Because there is no more element there, so we are not going to find anything. So when right is less than n, so while sum is greater than the required k, okay, and while is sum is greater than required k, what we are going to do, we are going to re- first decrease the element from the sum, right? Whatever the element which we are going to take off from the subarray, we are going to subtract that from the sum. So for that I am doing now. We're going to first subtract that and then increment the left pointer. So the other condition is if sum equals to k, so we are going to check the maximum max of max length, comma, again the same, just like how we did j minus I plus 1. Here j and I is right and left, right? So right minus left plus 1, right minus left plus 1. And then every loop we are going to increment the right pointer. That part we will do. And then if one more thing is, if right is less than n, like that, it means you can have this, but uh, yeah, I am having this condition once again inside the while loop, because whenever we are incrementing the right pointer, right? So it can be at one point of time go out of this array. Yeah, because this right pointer is incremented inside this while loop, and we are checking a condition after incrementing the right pointer. So we are just having that uh, condition once again. So for every loop we are going to add that element into the sum. So we are checking that, and then return max length. This is the conti- code for this. One thing we need to check out here is, here while sum is less than k, sorry, when sum is greater than k, we are going to subtract the uh, element in the first index, and then increment the first index, right? Whenever the first index is getting incremented, we need to take care that this first index should not exceed the last index, right? If the first index and exceeds the last index, that there exists no array. There should be, if there is a first element, first index and then last index, there should be some elements in between there, those two. If first index exceeds last index, it means there exists no such subarray, right? So we need to check another condition here as well. So when left is less than equal to right, this will work, right? This one is an optimal approach when the array has, positive elements inside it. Doesn't work for negative elements, because for if there is some negative elements, let's say minus 3 or so, right? If that makes the reduces the sum as such, right? Here we are incrementing the sum whenever, every time, and then whenever it is exceeding the required sum, we are subtracting that, the first element. But if there is a negative element in that case, what happens is, if you are subtracting that first element, you are basically adding that first element, and then you are incrementing that total sum as such. So this doesn't work for negative elements. For negative elements, you can use this approach, hash map, that works for whatever array you have, right? I hope all these approaches is understandable. And then here the time complexity will be, one will be first outer while loop. This takes O of n, obviously, because right pointer just goes from 0 to n. And here, if you see, there we are incrementing the left pointer as well, right? But this left pointer in the overall function goes from first index to last index, right? So it is O of n as well. So it will be O of n plus O of n, that is O of 2n. That will be time complexity. Okay. So I hope you understood this question. It's a very important question in the interviews. That's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.